Alright, this video is to just an extra set of questions to prepare for the third quarter test. Alright, and there's question 1 here and question 2 on the back, and I'm also going to look at these questions here, calc problems for test 3. Alright, I'm going to start on question 2 because it's the easiest. Okay, so it says the velocity of a particle in meters per second is described by v of t equals 0.5 t minus 2. Alright, so next it says find the distance the particle travels from time t equals 2 to time t equals 5. And distance is a tricky one. So for part A, if I set up an integral, okay, from 2 to 5 on the velocity, this will tell me the total displacement. Okay, so there's one problem with this. And if I create a sketch of the actual graph, this one starts at -2 and has a slope of a half. Okay, so it basically starts down here. And go 1, 2, 3, 4, 5. 1. All right, so it goes through here. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. All right, so this graph is that. Okay, and we're actually tracking from time 2 to 5. And this is backwards, and this is forwards. So what we're looking for is the area of those spaces right there. Okay, now one way to do this is just with the geometry, because like here's the problem. If you take this right here, it will actually treat these as distances that cancel each other out, and that's displacement, but the question said distance traveled. So I'm gonna have to treat both these as positive. One way to do that is with area, just using the geometry. This is 1 by 2, so the triangle there has an area of 1. This one right here is 1 by a half. So if I multiply those together and cut it in half, I will have 1/4. All right, so technically this is -1 because it's in the backward direction. This is +1/4 because it's in the forward direction. And if I did this integral right here, I would have to treat this as negative, treat this as positive, and give me -3/4. But that's not what they want. So the way we have to do it, we have to treat this as absolute value. Okay, so we have to treat everything as positive, which would be 1 plus 1/4, which would be 1.25, and that would be meters. Okay, a second way to do it, it would be to set it up as two separate integrals. So you could say the 0 is technically at 4, all right, and you could do the integral from 2 to 4, okay, absolute value, of the 0.5 t minus 2 dt, and then plus 4 to 5 of the exact same thing. So you could break it up and then force everything to be positive, which is really what I did. I think it's easiest to do from the picture because the graph is simple. It's just a linear. All right, for part B, again, our answer there was 1.25. If you did displacement, you would have ended up at -3/4. Okay, B, find the function for displacement called s of t if s of 4 equals 0. All right, so I'm going to integrate on V the integral of 0.5 t minus 2. Okay, and that's going to be t is raised to a squared. Dividing by 2 makes it 1/4. And then I raise it to minus 2t plus c. Then they told us that this is s of t so far, and s of 4 equals 0. We're going to use that fact right now. All right, so what I know is that 0 equals 1/4 times 4 squared minus 2 times 4 plus c. So I have an output, and the input goes in for the t values. And this value gives me, let's see, this is going to be 16 divided by 4, which is 4. Okay, and minus 8 plus c equals 0. That's -4. Add it to the other side. 4 equals c. So we're going to say that s of t equals 1/4 t squared minus 2t plus 4. Don't forget to restate the actual answer. It's a silly way to lose points. Okay, the next part, part C. In part C, it says find the equation of the tangent line to s of t at t equals 6. Okay, so I need to fill in the blanks. And slope x minus, so I'm going to fill those in right there. So I need to know s of 6. So I have my equation there, 1/4, 6 squared minus 2 times 6 plus 4, and let's put it on the next line. S of 6 equals 1. All right, so right now I know my x value is 6. Okay, I have my y value is 1. I'm missing my slope value, and that's going to be s prime of 6, which is the same thing as v of 6, because we go from displacement to velocity, and that's going to be a half times 6 minus 2, which is 1. So our slope is 1 also, and there's our answer. All right, part D. Find the average velocity from 1 to 9. Okay, so average value of a function uses an integral. We're going 1 to 9, and we're trying to find the average of velocity, so we actually use the half t minus 2 dt. And now what we typically do is we show a fraction in front for the divide by the width. The distance from 1 to 9 is 8, so technically we're dividing by 8, and we do that as showing a 1/8 in front. All right, so when I do this, I now have 1/8, okay, and the antiderivative here is 1/4 t squared minus 2t, and that is from 1 to 9. Okay, so 1/8. When I plug in the 9, okay, and then I'm going to have to subtract a kind of a big quantity here. 1/4, 1 squared minus 2 times 1, close, close. All right, so there's the fundamental theorem done. And when we calculate all this stuff, and it will all come out to 1/2. All right, let's put units on some of these things. Okay, so just so we know, this s of 6 was a displacement, that is meters. This was a velocity, this is meters per second. This is an average velocity, so it's meters per second. Okay, and there we go. Okay, for question 1, it says in order to investigate mail handling efficiency, each hour one morning a local post office checked the rate, and this is letters per minute, at which an employee was sorting mail to use the results shown in the table to estimate the total number of letters he may have sorted that morning. All right, so there's one tricky part to this. The one tricky part is that the letters per minute, I want to see that in letters per hour. Okay, so I'm just going to take each of these, I'm going to multiply by 60, so then that would be letters per hour. So here we would have 60, okay? 60 times 12 is 72. 8 times 60 would be, this is 600, 720. This is 480. 9 would be 540. And 11 would be 660. There we go. Okay, now I can draw a picture of this. And in this picture, looking at this, I'm going to go by hundreds. Okay, so 100, 200, 300, 400, 500, 600, 700. Okay, so I'm going by hundreds. 200, 300, 400, 500, 600, 700. Okay, and I need times. And at 8 o'clock, he basically sorted 600 letters per hour. Okay, and here it was 7:20, so 1 hour later we're up to 7:20, just a bit above that. Then we go to 480, so if this helps you to draw the picture, okay, we are good. And 540 for the next one, about right there. And then 660, about right there. Okay, so there's our graph, and we could actually use a left rule, right rule, and average them together. Okay, so you could do that and you could draw those rectangles in there. So what I'm looking for technically is the area underneath all these points coming down, because the area underneath here will be the total letters sorted that day by this person. Okay, so what I'm going to do now, I know that the width in each of these cases is 1. So I'm going to use the left rule, which means that I'm going to have 1 times 600 plus 1 times 720 plus 1 times 480 plus 1 times 540. Okay, the right rule is going to work backwards and ignore the first value, so 660 plus 540. In each of these cases, the width is 1, so I am multiplying by something. I'm just not writing it down because I'm running out of room. 480 plus 720. All right, so in this case, 600. Okay, if we average them together to give us a trap, okay, so I'm just going to take the 2340 plus the 2400, divide by 2. I'll have 2370. Letters. There we go. Okay, it says, hoping to speed things up a bit, the post office tested a sorting machine that can process mail at a constant rate of 20 letters per minute. The graph shows the rate at which the letters arrived at the post office. Okay, so it can only sort them at 20 per minute. All right. And the graph shows the rate at which the letters arrived at the post office and were dumped into the sorter. All right, so, okay, all of these are in letters per minute. If I multiply by 60, you see 600, 1200, and 1800. This is letters per hour, okay? All right, and it says find how many letters were sorted from 8 a.m. to noon. And the actual problem drew a line in here, and that matters because at this point right there, okay, the machine cannot sort as fast as they're being dumped in. But all this time to the left, it can sort all of those. Okay, so let's actually figure that out right now. In this piece right here, okay, this triangle is going to represent how many it's sorted from 8 a.m. to 10. So from 8 a.m. to 10, okay, we're going to do that area. And this is 2 by 1200. So 2 by 1200 divided by 2 because it's a triangle. So from 8 a.m. to noon, the machine can sort 1200 letters. All right, now just because this is how fast they're being dumped in doesn't mean that the machine can sort them all. So technically, okay, it can only sort these right here that are in this box right there. Okay, so that's what we technically want. This is going to be 2 hours by 1200. 2 hours by 1200. So it's working as fast as it can, and this shows that they're dumping more in than it can handle at a time. Okay, but it can handle all of these coming across. In fact, I could keep this going that way if I want, but we're only going to noon because it said 8 a.m. to noon. All right, so if we do this, this is 2400 because it's working at its capacity. It's doing as many as it can, all right, in this shape right there. This is extra stuff, just like waiting in its bin for it to be able to actually sort it. Okay, so our total there is 3,600 letters. So from 8 a.m. to noon, it was able to sort 3,600 letters. That's. As we work into this next part, I just want to point out, I'm not going to ask something as tough as this question was right there. Part B is a complete 5-level question, AP style, because there's so many conversions and so many tricky parts to it. There's 2 rates going on at the same time. All right, Part C is more reasonable, okay? And what it's saying is that A of t uses the graph from Part B. Okay, so there's the graph, and call this function graphed L of t. All right, and the area, okay, equals, so A of x, it says A of t here, it should say A of x. A of x equals the integral from 0 to x of L of t dt for 0 to 10, where x is the hours after 8 a.m., and it says find A of 6. So that means the area from 0 to 6. So we're looking at the integral from 0 to 6 on that. All right, so I have to pick to use either the 30, 20, the 10, 20, 30, or the 600, 1200, 1800. And I guess you could do it either way because it didn't specify. Let's just work with the smaller numbers, the 10, 20, 30. All right, and what we've got, well, let's do letters per hour. So I'm going to use the 600, 1200, 1800. Okay, so the heights. I redrew the actual shape, and we're going out 6 hours later, and 6 hours later is at 2 p.m. All right, and what we're going to find is that this height right here is 1200, okay, and this height right here is 1800. The distance across the bottom here, this is at 11, so we're at 11, which makes this 3. This triangle right here is 3 by 18 divided by 2. So if I do 3 times 1800 divided by 2, I'm going to have 2700. So the first triangle is 2700. Okay, next I've got a rectangle, and the rectangle here is 1 unit wide, okay, and it was 1800 tall, so it's going to be 1800. Okay, next I've got this rectangle, and this is going from 12 to 2, so this is 2 hours by 1200. 2 by 1200 is 2400. And then I've got this little triangle right there, which we're talking about right here. It's 2 wide and by 600 tall. So 2 times 600 divided by 2 gives me 600. Okay, so if I add up all of these things right here, 2700 plus 1800 plus 2400 plus 600, I end up at 7500. Okay, and that is letters. Technically, we're doing an area under a rate curve, so we found letters. And this is how many letters were dumped into the machine from 8 to 2 p.m. So that's letters, and this is dumped into the machine. Okay, to convert this to the average value of L of t, what we're going to do is just take how many letters were there and divide by the width. And we went from 8 to 2, that is 6 hours. So if I go 7,500 divided by 6, I'm going to find that's 1,250 letters per hour. All right, keep in mind, part B is crazy difficult. Part A is reasonable, except for we had to convert by multiplying by 60. All right. Part C, just do you know how to use an accumulation function? Knowing that you're doing the area from 0 to 6. Okay, break it up. And our units would be letters. All right. And then finally, average value of the function. I take that area and divide by its width, and I end up back at letters per hour. Okay, let's look at this next piece. All right, calc problems for test 3. All right, it says f of x equals the radical 10 over x. Okay, so first, in order to work with this, I'm going to clean this up a little bit. You have to know that you can split this into the radical 10, radical x. That's a legal move. And I can now write this as radical 10 x to the negative half. All right, so that's probably the most user-friendly way for calculus to use this function. All right, so to find the derivative, the negative, this is just a constant, okay? So this equals, I've got my radical 10 in front, the negative half will come down, and the x will then decrease in power by 1, so negative 3 halves. Okay? Next, find capital F, which is the integral. So I'm going to have to integrate on radical 10, which I'm just going to move in front, of x to the negative half dx. Okay, so I've got my radical 10. I increase the power by 1, okay, which makes it a positive half. I then divide by a half, which puts a 2 in front, plus c. So right now I'm at capital F of x equals 2 radical 10 radical x. Okay, and you could make this whole one radical. So just like I split this up, I can take the split version. I could write it as 2 radical 10x. That's a legal move as well. All right, now, and one of the reasons I can do that, there was no plus or minus. Everything was multiplication division. So that's what allows me to break them up and combine them. So if there was a plus 1 or anything like that, it would mess everything up. All right, it would change everything, I should say. Okay, now, the condition they gave me was 1 equals 1. So I know that 1 equals 2 radical, it was plus c. All right, so 10 times 1 plus 1. All right, so there's where I am right now. Oh, plus c, excuse me, plus c. All right, okay. So now I'm trying to solve for c. Just to recap what I just did there. My input was 1, my output was 1, so I plugged the output in there, the input in there. I still have my unknown value plus c, okay? And now I'm just going to solve for c. So all I have to do is subtract. So if I do 1 subtract 2, radical 10 times 1, which is just 10, that will equal c. Let's find out what that is. 1 subtract 2 square root of 10 is negative 5.32. So here we have f of x equals, and it was 2 radical 10x minus 5.32. There we go. In the second question, it's actually kind of difficult because it does not drop in degree from inside to outside. So I'm going to set u equal to the inside, the x plus 10. And because it doesn't drop, I'm also going to show that x equals u minus 10. So I solved for x. Now, either one of these I can solve for. Du equals dx. And now I'm going to replace everything in terms of u. So the integral, and x is going to swap to be u minus 10. And the inside goes to u, so I'm going to have the square root of u, which is u to the half. And dx is replaced by du. Now I'm going to distribute the u to the 1/2 into the parentheses. So I now have u to the 3/2 minus 10 u to the half du. Okay. Now I'm going to do an antiderivative. So at this point, I'm going to raise the power by 1, divide by that new power, which is 2/5. Okay. Same thing on the other one. I've got a 10 there, and I'm going to raise the u to a 3/2 and divide by that, which puts a 2/3 in front. Okay, I'm now going to switch it back to x's. So when I switch this back to x, I have 2/5. And u equals x plus 10, so I'm going to have x plus 10. And that is taken to the power 5/2. Okay, minus, I'm going to write that as 20/3, x plus 10 to the 3/2. And that is then taken to, I went big stick from 1 to 2. I can use the limits of integration because they were back in x's. So the 2 is going to go into this, and the 1 is going to go into this, and we'll just type that into the calculator. Okay, plugging in the 2 gives us negative 77.6. Now I'm going to replace the 2's with 1's. And I have negative 82.7. Okay, so negative 77.6 minus a negative 82.7 gives me 5.1. All right, and I can double check that, and I can double check that by just going x square root of x plus 10. All right, now from here, just graphing. Second, calculate. 7, 1, 2, 5.1. All right, so it worked out both ways. All right, next. Okay, so we're supposed to do the derivative on an integral. Okay, so we're doing forwards, backwards, and we have a constant and x. That's what we want. So therefore, my derivative is just going to be the tangent of 4, replace t with x, and it's done. You don't have to do anything else because it's a forwards, backwards question, a constant to x. And there we go. All right, this next one is on here to see if you can break the fraction up into all the separate little fractions. So if I take x to the 4th, x squared, okay, that's going to simplify to x squared. X over x to the 1 is 1 over x. Okay, now I have x to the half over x squared, which I will simplify in a second. Okay, next I have 4x squared over x squared, which is 4. Okay, keep it going. And I'm just simplifying, trying to make it in a form where I can use the power rule. Negative 1. All right, now for a trickier one. When I divide these x's, I have to subtract the powers. A half subtracting 2 gives me negative 3 halves. Okay. And now it's in a form where I can raise them and divide by the new power. So let's actually do an antiderivative, which means we're going to stop writing the integral. 3 divide by 3. Okay, next, raise the power by 1. Okay, so 1 over x. If I raise the power by 1, I end up with a 0 and divide by 0, and that's a problem. All right, I'm going to make that a 3. This is going to give me a regular x. Makes that an x. All right, and then, okay, that's better. So now when I raise it to an x squared, divide by that. Okay. Next, I'm going to raise the next one by 1, which raising it from negative 3 halves by 1 gives me a negative 1 half. Dividing by that will give me a plus 2 in front, plus 4x, plus c.